My name is Stephen Alonzo, and I'm a flat earth scientist. I'm pushing the boundaries of where modern science has failed. I'm going where no one else before me has gone.
Dr. Stephen Alonzo here of the Flat Earth University, and it's been a while since we last talked. I've been up to a lot of stuff in my personal life lately, so I'll give you guys an update on that. But I was recently inspired to make a video after watching the modern day debate. It was Iron Horse versus William, and it made me think the major reason that people believe in the globe is that they have no understanding of the flat earth model at all. And we'll see that as we go through about 9 of his points in his introduction. He's confused about how direction of light works, how south celestial poles work, the stars and constellations. He accurately describes how the globe works, which is fine. In the theoretical model, you should, as a flat earther, also know how the globe works. But for flat earth, he had no real answer. He said, I don't know, and that's a problem. For us as flat earthers, we need to understand the flat earth model, which you should, but then also the globe. On the contrary, it seems that globers have no idea how the flat earth model works at all. So we're going to be going into that. In my own life, I've been continuing with the Flat Earth Fitness muscle building program. You've probably seen plenty of my live streams 6 months to a year ago, way back when the final experiment was happening. You'll see me doing push-ups and stuff. So I've been continuing with that, and the muscle growth is noticeable now, and I'm quite proud of the frame that I built. So in the next few months, I'll be working on losing body fat to get that ripped, shredded look. Now, 5 years ago, I did that before. So this picture up here is from 5 years ago, and it is when I lost weight. I used to be really, really fat and went down to a really low body fat percentage. However, I didn't like how I looked because when you used to be obese, you're going to carry some loose skin at the bottom, as you can probably see in that photo. And you only have 2 options. You either got to go and get surgery to have it removed, or you spend the time building muscle so that your chest pulls it up, your abs stick out. And that's what I'm trying to do now. So hopefully this time when I cut down, it's going to look really good. And I think it will, because I have now a significant amount of muscle that once it all tightens up and the fat's gone, I may be ready to do a bodybuilding show for all we know. Now, I've been coaching people in fitness for a long time, and if this is something that you're interested in, you can schedule a free consultation. I try to give you honest, straightforward advice and something realistic that you can stick with for years, because this is something that takes a long time to see results. Now, what I've been doing is working out about twice a week, sometimes 3 or 4, but the minimum commitment is twice a week, and you can get about 80% of the results as someone who is going every single day, doing a 6-day-a-week workout. And that's realistic. This is something that you can stick to and commit to. And most of it has to do with nutrition. It's not really about training as hard as possible. It's about eating the correct foods to allow your muscles to grow. For example, you need 1 gram of protein per pound of body weight. If you weigh 180 pounds, you need 180 grams of protein. Read the back of your food labels, add it up, and you're going to see you're deficient. Most people are. So it's very basic, trying to get a good understanding of nutrition and get a workout plan that you enjoy doing and that you can commit to. So definitely talk to me if that's something you're interested in. Now, the Glyphs on Ice book is still in progress. I had a lot of people emailing me about this. This originally started last year when we did the final experiment and found out that the flat earth model does absolutely predict a 24-hour sun. This book I put on pause for a little while for a few reasons. One of the major reasons was my girlfriend. She's an American, and as you know, I live in Belize. She was going back home to her family now, and she's not going to be back for over a year. So for those last times that I had with her, my free time was dedicated to her over other aspects of my life. For example, I wanted to be cuddled up next to her on my Gleason Blanket, link in the description if you're interested, and just enjoy life. So the book now, I realistically think 2 months, maybe 3, Many of you pre-ordered that. You're still going to get it sent out at the cost you pre-ordered. You're going to save money, and then I can't wait to start selling this to other people. It goes into not only the final experiment, but the math and science behind why every flat Earth model requires and predicts a 24-hour sun at a certain point in Antarctica at a certain season, and why there's no reason to deny that. Now, you might also notice I have another book behind me. This is The Creation of Earth by Dr. Jessica Wood. She runs a very popular Facebook channel with 80,000 followers, and I purchased her book, and it's absolutely phenomenal. I think everyone should have a good understanding of the biblical cosmology version of flat Earth. And very basic example is a lot of people are still arguing with me about the location of the celestial objects. Is it above? Is it below? No, it's on. We've established this a long time ago. The science and math tells us that all celestial bodies are physically on the firmament, not above, not below. This is how dome refraction works. You can't have an accurate flat Earth model if you have the celestial bodies below. You could have them above, for sure, but you can't have it below. The key concept is that light has to shine through the firmament to get what's called dome refraction. This is how we get a 24-hour sun. It's how we get south celestial poles that rotate in opposite directions from the north. This is extremely important to understand. Now, the Bible and its depiction of our universe matches what the real science and math tells us, what flat Earth science tells us, not what globe pseudoscience tells us. But if there is a religious book that is telling you exactly how the Earth is, and it matches with all the flat Earth science, you should understand this. So I don't really like how people still argue with me saying that the sun is below the firmament. That's not valid from a scientific point, and it's not valid from a biblical point. Now, let's get into the modern day debate that's going on right now, because he brings up a lot of points, and you'll see that from his introduction, he doesn't understand anything about flat Earth. He knows a lot about the globe, but that's like being an expert in theoretical physics and trying to argue with someone who's doing applied physics. Just as a very basic example, if you don't understand it, you can't really contribute to the discussion, and you don't have enough knowledge to be participating in that. So let's go to the video.
And spacecraft design. And today, I want to take the opportunity to describe and explore the differences between the two models, the globe model and the flat model, and what they predict and how that compares to what we see in reality. So let's get started. So the first evidence that was gathered about this was from Eratosthenes over 2,000 years ago. Essentially, we know that if the Earth was flat, that there would be an asymptotic trend of shadow angles over the latitude of the planet. And if the Earth was spherical, there would be a linear trend of shadows across the latitude of the planet. And it turns out, after measuring it, we do have the linear trend of shadows across the surface of the planet. We see, on a flat Earth, you would never see a 90-degree shadow, and on globes, we see 90-degree shadows near the poles all the time, and even not at the poles, you see 90-degree shadows at sunset every day. So we know that would only be relative to a globe Earth. So that wins.
Now, he's wrong about that. Let's go back so you can see the shadows. The globe angles actually match the flat Earth angles. Now, there's something important to understand. This is why you have to know that light shines through the firmament. If you have a flat Earth model like what he showed, where the sun is under the dome as like a physical thing going in a circle, the prediction he showed is right, but that's clearly false. And if it was that easy to falsify flat Earth, no one would believe in it. So this is from the Firmament Tracker's Flat Earth app, the hat I'm wearing, but it's a multi-observer. It's actually the only multi-observer astronomical model that exists. globe models just can't do this. I don't know whether it's because globe programmers just aren't as smart as me, or if you actually physically can't develop it because the globe just doesn't exist. The best you can have for a globe model is a single observer at a time, like Stellarium in first person, but this is third person and first, so you can get a really good understanding of how the world works. But as you see the sun, it is physically up there on the firmament, and as you see observers, it rotates around, so you can face away from that object and still have it visible. This is not only important for the 24-hour sun, but also important for understanding those angles that he was talking about, stuff like the equinox. Intuitively, it might not make sense how you can have a bunch of right angles, but when you understand that the light is refracting through a medium, it begins to make perfect sense. So this is why it's so critical to understand that all celestial objects are physically on the firmament shining through. Let's go back.
Across the surface of the planet. And flat observation, and what do we see every day? We do see stars going in a straight line across your head. A circle of stars going around a pole on the north side of yourself, and stars going in a circle on the south.
So again, the same issue here. He gives us a flat Earth model that is clearly false, and we know it's false because we have people who live in New Zealand, Australia, who are flat earthers, and that's not the observations that they see at night. We know that what he's showing for the globe is actually what happens on flat Earth. It's important to understand that the flat Earth model does have south celestial poles. This is nothing to be confusing about. It all has to go back to that dome refraction. You have the opposite rotation in the north and the south, just like what he's showing for the globe. And we know this. Like, you can test this yourself. Like, people in Chile and New Zealand who are flat earthers look into the sky every night. So it's very important to understand and use a correct flat Earth model. So that's why, like, this photo right here is from the Firmament Tracker's flat Earth model. It is accurate, and it's how the world really works in real life.
South pole side of yourself if you're standing on the equator. And that differs from predict there would probably be other planets orbiting the star, and we would be able to observe those other planets from our perspective. And we would see specific movements from our perspective that are very identifiable, especially one called retrograde motion. This would be very clear. This is a direct prediction based on orbital mechanics. And what would a flat earther say about movement of planets across the sky? They would say, I don't know what planets are, I don't know why they're moving, I don't know how they're moving, and I can't really predict where they're going to go either.
So the same issue as before. Now, I didn't make a slide for this. I forgot that this was in his presentation, but planets do exist. They are spherical. The celestial objects above us have no relation to the floor. If you find a problem with planets being spherical, that would be like, why is my light bulb a sphere but my floor is flat? There's no association between that. So planets exist, they are spherical, and their paths are observed, they can be predicted, they're just all on the firmament going around. Now, why do some planets change their path? We don't know. Now, we believe they're their own independent bodies that are set in motion. And retrograde motion is like literally what he's showing there, a planet doing its own path. And it can be predicted the exact same way through the exact same formula he uses. It's not a big deal to accept that planets exist and they have their own independent paths that they sometimes take.
So which of these models has better predictability? the globe model has better predictability. Lunar eclipses, if we were on a globe, we would predict that eventually the globe would obscure the sun that illuminates the moon, and it would project a shadow onto the moon, and that shadow would be circular every time because we're on a sphere. The penumbra and the umbra would be circular, and we could not only predict it would cast a shadow, we would predict when it would cast a shadow and where it would be observable from the Earth, down to the second. That would be true if we were on a globe. But if we're on a flat Earth, there's really no explanation of why there's any kind of lunar eclipse.
So again, it goes back to that same thing I told you from the beginning. He doesn't know anything about flat Earth. He has an explanation for how it works on the globe, and there's nothing wrong with that explanation. If the globe model is true, that is how an eclipse works. But the problem is that he doesn't know anything about flat Earth, so therefore the globe must be real. It's a ridiculous and kind of scientifically ingenuous view to have. That's why I think it's important that we teach globers how stuff actually works. Like, we don't need to necessarily point out that the globe has like a Lucifer crest in their eclipse model and how ridiculous it is. Like, it's clear that the globe's lunar eclipse is inspired by Lucifer, like Lucifer's signal there. But we don't necessarily need to point that out. We can show them how it actually works on flat Earth. Now, just like on the globe, the ground position, which is a latitude and longitude of the sun and moon, are well known and not debated. Any flat Earth model you look at is going to show you the correct location of the sun. Most of them, though, are only from a sky view down in 2D, which is fine, but you will see that during a lunar eclipse, the sun and moon are always on opposite sides of our flat Earth. The sun, being close to the edge of the firmament, causes what's known as a coffee cup caustic effect, where the light wraps around. And as the moon enters into that focal point, you can see exactly what we see in real life. You look up in the sky and you can see that kind of the sun intersecting its light with the moon. That's how a lunar eclipse works on flat Earth, and it makes perfect sense. You can test this yourself from a smaller scale model. I believe that middle photo I have in the top is from Joseph Hanby, who has the dome firmaments himself that he conducts optical experiments with. And it's quite fascinating, and it makes a lot of sense.
That wouldn't really make sense in that model. And there's not really any logical reason on a timeline either. In the South Pole, you'd predict if you're on point D on the South Pole or point E, as you can see, you would be able to see the Southern Cross. It doesn't matter what side of the South Pole you're on. But if you're on the flat Earth, if you're on point D, maybe you could see the Southern Cross. But if you see it there, then it wouldn't make any sense for you to see it on point E, right? Because it's on the opposite side of the flat Earth. So what would you see there? I don't know. Nobody knows because they don't really give any more information than that.
Well, we do know, and it's quite obvious as well. So let's go to, what do we want to look at? So this is why it's important to understand the concept of dome refraction. So you see the sun up there in the top left, and you see the four observers at four of the South Poles facing away from each other. You can have your back to the physical object, but because it's refracting through the firmament, that point A to point B of light is visible. And I want to make sure that we understand one thing. Is it in star movement here? His picture is wrong for what the flat Earth prediction would even be, assuming you could see it. You're not going to see it at the same rotation. That's extremely important to understand. So here I have four observers, and you see that black cross? If you look up really close, you'll see the four stars as well for the Southern Cross. But it's going to be rotated depending on what part of the firmament you're looking at. And this is even confirmed with globe models such as Stellarium. You will have an observer in Chile, for example, seeing the Southern Cross on their left side. That's what that circle is there. Whereas if you're in New Zealand at the same time, you would see the Southern Cross near the bottom right. It's rotated depending on what part of the firmament you're looking at. It's not going to be the exact same angle of orientation. Now again, this has to do with dome refraction. When you shine a light through a firmament, it's going to wrap around. And as you can actually see from that top right photo, it's a very good example of why the Southern Cross is visible for people in New Zealand, Australia. They're close enough to the edge of the firmament that the refracted light going through lets them see it. And it's going to be rotated. That makes perfect sense. This is how dome optics work. And again, that's why it's very important to understand that you're not looking at a physical object under the dome, because if so, then he would be right. You're looking at a celestial object shining through a dome firmament. Very important to understand.
So can you see the Southern Cross on point D and E? The answer is absolutely. That is very consistent with naval observations. Win for globe again. Flight times. These are 2 flights that I took from flightaware.com. I encourage everyone to go do it. Flight from Seattle to London went about 6,500 miles and took about 10 hours. And the same is true for a flight from Chile to New Zealand. It was about the same length and about the same timeline, which is what you expect on a globe because it's about the same distance and about the same time. However, on a flat model, it completely turns out on its head because it is about 3 times the distance if you use this type of a flat Earth map. I can't even tell you the exact time it should be because on a flat map, the geometry doesn't really make any sense. But you can clearly see it would be 3 times the length, therefore should be 3 times the time it should take to fly that distance. Is it 3?
Now this is a good one because not a lot of people... Oh, sorry, I didn't even play that for you. Let's go right back so you can see it. He's talking about flight times. So you see what he's showing, right? Now, again, these times are well known. They're not debated. You can time it yourself and take these flights. The issue is that many people haven't researched this and many people don't have a good explanation for this. The way that I explain flight times is using what's called the Lorentz ether length transformation theory. So a lot of you guys are familiar with the ether. We on Flat Earth do believe there is an ether. Now it's important to understand that this ether is contained within the firmament. It's not throughout the whole universe. So if you were to go outside of our firmament, there would be no ether. Now this is important. I'm not just making this up. It's required for this framework to work because what happens is there's going to be a compression of ether. So when you're at the bottom of the firmament and you only have, let's say, this much room, that ether is going to be compressed. Whereas when you're at the North Pole, there's less of that compression. Now, as you travel through the ether, the Lorentz ether length transformation lets us adjust for a relative distance. You can kind of see what I'm talking about in this photo up here. The length of the pencil, one person sees it as 4 units, another person sees it as 5 units. This is why if we were to go up into space and look down at Earth, if it was possible to be up on the firmament looking down on it, we would see a Gleason map. This is what the world actually looks like in real life, and it's important to understand that it's not distorted at all. All distances on flat Earth measure correctly when you account for the ether and the length transformations that happen as you travel through it.
Times the time? Is it a 30-hour flight from Chile to New Zealand? No, it's a 12-hour flight, not even close. So another win for the globe, just stop being hurricanes. That would be true if you're on a globe. That's what it would predict. On a flat Earth, there should not be any Coriolis effect at all, because it's not rotating. However, let's say the sky's rotation around the stationary Earth does have an influence on the winds that are underneath that sky. So it does cause some wind from the sky's rotation. Then there would be a Coriolis effect. However, that Coriolis effect would be the same for the North Hemisphere and the South Hemisphere of that flat Earth. There would be no difference between the hemispheres. So the hurricanes would all spin in the same direction. Is that what we see in reality?
So he's partially correct, but it's important to understand that the firmament is what's rotating. We know that the firmament rotates at 15 degrees per hour. So over a period of 24 hours, we get that 360-degree rotation. This is well known. It shouldn't be too debated about. And even experiments that claim to have measured the globe's rotation, they're actually measuring the firmament's rotation. It can be deceptive. Whether the sky is moving or Earth is moving, they're kind of inversely connected, and it can be hard to tell the difference. But on flat Earth, it's the firmament that's rotating. Now, what he is saying, you see how there is that outer arrow? He's trying to say that you would kind of have the wind going like that, making that type of pattern, but that wouldn't actually be true because that's where the firmament touches down. There's not going to be any wind there due to the parabolic structure of the firmament. In the middle part, which is where the globe's equator is, that is where the wind current will be going. So just like how the globe has the wind going in one direction around the equator, on flat Earth we also would. It makes no difference. And observations like these are correct because whichever model is true, the other one was reverse engineered from it. Globe theorists and the Luciferians and the Freemasons, they're not stupid people. They took the working flat Earth model and reversed it so that everything the globe predicts would be the exact same as what flat Earth predicts. That's why this discussion is not as simple as just explaining how the globe works and saying it doesn't on flat Earth, because they make the same predictions. And if it was that easy to debunk flat Earth, no one would believe in it. Like, we would have to be stupid. Okay? The way he is presenting it is that flat Earth explains nothing and that the globe explains everything. But if that was true, we would all believe in the globe. It's way more complex than that.
What kind of hurricanes do we see in reality? We do see the globe prediction. They do spin in different directions, and no, they never ever cross over the equator. This is my last slide for the hard evidence. This is my favorite one. It's for gravity, because it basically is helpful in predicting so many things. This is a list of a few of them. Number one, we can predict the results of the Cavendish experiment. We can predict the motion of projectiles in every category, from baseballs to nuclear bombs. You can use gravitational equations. You can predict the outcome of the Foucault pendulums, of how they move. You can predict the outcome of the Heffel-Keating experiment. You can also predict that we would have an atmosphere, because although atmosphere is very low density, atmosphere is made of atoms of gas, and those atoms have mass, and mass is attracted to mass with gravity. So it would still cling to the very massive object, which is the Earth, in the vacuum of space. You'd predict the tides of the ocean using gravity, because the tides of the ocean is a influence from the gravitational effects of the moon around the planet. You'd predict optical lensing observations that you would see from deep space, which is a result of modern relativistic theory from gravity. You could also predict the shape and motion of not only the Earth, but the moon, the sun, all comets, all asteroids, all planets in the solar system, and all stars in the galaxy, and all galaxies in the universe using gravity and gravitational equations. It is the most validated concept in all of science, and if you are denying its existence, you're basically a fish denying the existence of water. So what can flat earthers do when it comes to this kind of phenomena? They have nothing. They can't predict these types of things because there is no a set of equations that are going to be logical.
So again, this goes right back to just not knowing any better about flat Earth. Now, he's not entirely wrong about this, because a lot of junior level flat earthers do deny gravity, and that is a terrible thing to do, and there's no reason to deny it at all, because he's right. Nothing works if you deny gravity. Now, how gravity works on flat Earth, it's important to understand that because gravity is real and we can test it, predict it, that has to mean that Earth is an infinite plane. Not Earth itself. Earth rests on an infinite plane. Similar to how in the globe theory they have an infinite space, we have an infinite plane that Earth rests on. This is important because the equations that are well established in physics, I'm not making this up, is called Gauss's law of gravity, and it's expressed as an integral. So this is getting into calculus where we talk about quantities of infinity, but what it does though is it lets us get the gravitational field for an infinite plane of mass. Now, why does it have to be an infinite plane and not a floating disk in space? Because of how gravity works. If you had a finite surface, that would mean the gravitational vectors. For example, when you drop something, right now it's going straight down because we live on an infinite plane. But if we lived on a floating disk in space, when I drop this, it would go towards the North Pole. So you can easily test this and know that it's not possible to live on a floating disk in space. There is no edge that you can fall off of. And people have been to Antarctica. People go to the South Pole, fly up in drones and stuff, and see that we absolutely do live on an infinite plane. Because we live on an infinite plane, the symmetrical spread of mass results in perpendicular gravitational vectors. So that when you drop something or release like a helium balloon, it's going straight up or straight down. It's not going towards the North Pole. That's very important to understand. So this is Gauss's law of gravity. You can look it up yourself, play around with the equations, and it lets us predict how gravity actually is. Now, Gauss's law is a derivation of Newton's law. So to be very clear, we're not talking about Einsteinian relativity. I don't believe in that. The globe uses relativity to describe space and all that stuff. That is a derivation of Newton's law as well. So Newton's law is correct. Now you can do a theoretical derivation of that to get Einstein's theory of relativity, but that's false. Or you can correctly derive it to get Gauss's law of gravity on infinite flat planes. This is the equation that we use to represent gravity on flat Earth, and you get the exact same 9.8 meters per second that you get on the globe. Like in real life, if you measure it too, you let go of a helium balloon, point like a radar gun at it, how fast it accelerates, you can easily calculate that as 9.8 meters per second. We know this. And that allows us to then do everything he said: Cavendish, projectile motion, nuclear bombs, if the moon has a mass, how the tides work. None of this we should deny, and I've never heard a valid reason as to why we should deny gravity. It seems to be something that people like Jaron, Nathan Oakley, Flatsoid, Eric Dubay, they all say this. I don't know if it's just for attention or if they just don't know better, but it's nonsensical to make such a claim. And again, you have no working model, you have no set of equations. So I strongly encourage anyone who's getting upset at me for trying to explain this, just search up the law yourself, and if it makes sense, and the only reason you denied gravity is because you thought it doesn't work on flat Earth, well, here you go, now it works. So I believe that covered everything, and then it's a 2.5 hour debate, but the whole reason why I wanted to talk about this was because Globers don't know anything about flat Earth. And that seems to be one of the major reasons why they believe in the globe and why new people to flat Earth can also be misled. It's hard to find proper flat Earth science where we believe and explain how the 24-hour sun in Antarctica works. For example, me with the Flat Earth University, we have no reason to deny that because not only does it work on flat Earth, it's also predicted by the flat Earth model. South celestial poles we believe in, but people like Flatsoid will say it doesn't exist, or people like Nathan Oakley say we make no claims, and it ends up creating a group of people who stay at the junior level and never make it to a senior flat Earth researcher. Now, flat Earth is all about self-improvement. It's not only about fitness, it's not only about becoming healthier, a better person. It's about learning new concepts, challenging yourself, asking questions that your leader might have told you you're not supposed to talk about. You can study this stuff and learn confidently how it works, and you can escape the level of a junior flat earther. And my goal is to help you become a senior level flat earther. Thank you for listening to this presentation.
What is flat Earth science? Well, it's asking the questions other people are too afraid to ask. It's the willingness to face any challenge, knowing that failure is how we get better. It's about testing our hypotheses using first principle concepts.